I have this titled Lesson 4.5 Part 2 because in the book it's the official second, it's still in Lesson 4.5. But we are talking tangent and cotangent. Okay? What I have tried to put up here for you are kind of like what I did in sine and cosine, where you have the initial graph looking at you. Now, we're going to talk about what all this means and, the pieces and all that, and then we'll go through and do some examples. So the first one we're going to look at is tangent. Okay, so what you're looking at is the graph of y equals tangent x. Now, it's harder to get them on my graph here. There are officially arrows on these graphs, so they do extend indefinitely. Okay, so I'm going to go through and put those on. I would encourage you guys to put the arrows on there because we should see the arrows. But what we're looking at here with tangent, okay, tangent, if you ask me, this looks like a y equals x cubed curve, right? Looks like something we've drawn. It looks like y equals x cubed, but here's the deal. It repeats. Okay, so there's this curve. Then a cycle later, there's another curve. Guess what? A cycle later, there's another curve. And it keeps going on and on and on. Okay? When you look at it on the calculator, you will see repeating curves over and over and over. Now, I don't know if you can tell it by looking, but those those vertical lines there are asymptotes. So what you have happening So what you have happening is you have these curves repeatedly over and over and over, but there are asymptotes happening in between them. Okay? So when we draw this, our job's going to be drawing the curves with the asymptotes in between them and then the curves. Okay? Now, some pieces of information. First of all, with tangent, this is a big difference. Our period for one tangent curve is pi. With sine, cosine, and thus secant, cosecant, one cycle took 2 pi, right? It took us from 0 to 2 pi. With tangent, one cycle is a length of pi. So what you're actually looking at up here is 2 cycles. And when we draw tangent and cotangent, I'm actually going to ask you to draw 2 cycles. So I'm always going to want you to draw 2 curves. Now, when you draw tangent, you'll notice here, for tangent, it says the first thing you'll draw is the dot on the origin. Okay, so the idea that, okay, this is a 0, this is where we cross the x-axis, right? There's a point, you always start off with tangent with a point at the origin. Of course, now if there's a phase shift, that's where we'll adjust. And then you're going to have one dot once a period. So if your period is pi, then you're going to have another dot at pi. If I kept going, I'd have another point at 2 pi, 3 pi, so on and so forth. Now, your asymptotes are going to be halfway in between. So if I have points at 0 and pi, I'm going to have an asymptote at pi over 2. Okay? If I have points at pi and 2 pi, I have an asymptote at 3 pi over 2. So I'm having an asymptote once every period. Okay? So you have a point once every period. You have an asymptote once every period. Okay, so my points are pi apart. My asymptotes are also a distance of pi apart. Okay, now, some connections I can make. And I don't know how much, this will make more sense come next chapter, but one connection that I can make, we'll talk next chapter that tangent of x is equal to sine of x divided by cosine of x. Which really we've already talked about a little bit, because do you guys remember me talking about tangent being y divided by x? Okay, and if tangent is y divided by x, well, that's sine divided by cosine, because sine is y and cosine is x. Okay, now, what this connection means, okay, sine is the top of the fraction. Anytime that the sine graph would have a 0, then that means there's going to be a 0 on the tangent x graph. Okay, so the sine graph has the same zeros as the tangent graph, is what I'm trying to say there. Because 0 on top of a fraction makes a fraction equal to 0. Okay, now, anytime cosine has a 0, well, guess what? That means tangent's going to have an asymptote. Okay, we can't divide by a 0. So anytime cosine equals 0, you're dividing by 0, and dividing by 0 just doesn't work. Okay, so any time there's a 0 on cosine, it's going to become an asymptote on tangent. Okay, so that is some information there about drawing tangent graphs. Now the catch is we're still going to have period changes. We're still going to have phase shifts. Okay, we're still going to have to talk center line. Amplitude's going to change a little bit. Okay, but we're still going to talk about amplitude. Okay. Now that's tangent. Got it? Cotangent. Very similar. Has some slight differences. Okay. So first of all, with cotangent, just like with tangent, the period is pi. Okay. So your period is pi. A difference with cotangent is the first thing you'll draw is the asymptote on the y-axis. Up above, the first thing was the dot on the origin. Here, at the origin, you're going to have an asymptote. So you'll notice here at this cotangent graph, 0 is an asymptote. Now, similar to what we would think with tangent, once every period these things happen. So if you have an asymptote at 0 at the y-axis, if my period is pi, then that means we're going to go to 1 pi. There's an asymptote. Add another pi. There's going to be an asymptote at 2 pi, an asymptote at 3 pi, 4 pi, so on and so forth. And then this time, if you're drawing your asymptotes first, what does that mean falls in the middle of each cycle? Those are your zeros. Okay, those are your zeros. And what's the other difference you noticed that I've probably skipped over? Tangent was an increasing graph. It looked like x to the third, yes? Cotangent is what I would call a decreasing graph, because as you travel to the right, it's going down. Okay, it's basically a reflection of tangent, but instead of going up, starting low and going up high, it starts high and goes down low. Okay, now I can relate the same thing I did up there, and that is that cotangent, keep in mind, cotangent is the reciprocal of tangent. So that means if tangent is sine divided by cosine, cotangent is the cosine of x divided by the sine of x. Well, what this changes, since cosine is on top, anytime cosine equals 0, this fraction equals 0. So a cosine 0 is going to result in a cotangent 0. Any place cosine would cross the x-axis, that's where cotangent would cross the x-axis. And a sine 0, well, now sine's in my denominator. When we divide by 0, we can't divide by 0. So anytime sine is 0, there's going to be a asymptote with cotangent. Okay, it's just good extra information to be familiar with. Helps us understand the graphs a little bit, and it will make more sense also next chapter. Okay. You'll notice the next thing on the paper. Okay, y equals a times tangent of bx minus c plus d Do those pieces sound familiar? Same thing we had with sine and cosine. Now, with that in mind, a lot of pieces are going to be the same, but there are some tweaks, okay? First of all, normally we talk about A being the amplitude, okay? Officially here, amplitude was how far we stretch the graph up or down, right? Like instead of just having a normal height of 1, maybe we had an amplitude of 3, so it stretched the graph 3. Okay, amplitude here, we don't have a max height and a max, a minimum spot we go. We don't have those. So we're going to talk more about A being more of just a vertical stretch or vertical flatten. And I'll demonstrate that a little bit, but a vertical stretch just means your graph is going to go up steeper. Okay, it's not going to curve as much around the x-axis. Where a vertical flatten means, okay, we're going to travel more kind of along the x-axis. And as I said, I'll demonstrate that's going to be the easiest way for that to make sense. But so if the number is bigger than 1, you're going to stretch it. If the number is less than 1, we're going to flatten or basically like a shrink, right? So that's your A value. Again, if A is negative, we're going to reflect the graph. Okay, guys, here's a big one. Did you catch this? What about the period?
Pi over b.
It's just pi over b, as opposed to 2 pi over b. Now, logically, that should make sense. Sine and cosine had a period of 2 pi, so we did 2 pi divided by b. Tangent and cotangent have a period of 1 pi, so we're going to do 1 pi divided by b. B is still in your same location, coefficient of the x value. Phase shift is still c over v. It's still going to be opposite the sign. Center line is still your D. Okay? So, biggest thing to watch out for, the period change. Okay, you ready to try one? Let's try one. Okay. So, y equals 2 times the tangent of 6x plus pi minus 1. I'm still going to go through asking some questions. I'll still start with center line. We have a center line of what? -1. The D value added or subtracted at the end, yes? Now, normally I do amplitude next. I'm not going to talk amplitude. What is my A value here?
2.
My A value is 2. Is that a vertical stretch or a vertical flatten? That's going to be a vertical stretch. So what I'm going to write down is that we're going to have a vertical stretch, and it's by a factor of 2. Okay? Let's see. No reflection to worry about because my vertical stretch value was positive. Let's talk about the period.
5/6.
Okay. It's pi divided by b. So it's a pi divided by 6. Okay. And let's talk phase shift.
-5/6.
What do you think? C over B opposite the sign, so -pi/6, which means officially we're moving left pi/6. Okay. Now, I'm jumping us full in. I'm not giving us an easy start here, am I? Okay. So we're jumping full in, but you guys have an idea of how these things work. It's a little different with tangent, cotangent, but that's all right. Oh, speaking of which, what graph are we graphing here? That's good to know. We're graphing tangent, yes? Okay, it's a regular tangent, not reflected. Tangent is an increasing curve. So you guys know how I like to draw a little picture here to remind me. That's my little picture that I draw for tangent. Just the fact that it's an increasing curve. Not that you guys have to draw a picture, but that's what I usually tend to think about there. Okay, so let's start. Let's label center line. Center line is
-1.
-1. Label it out left or label it at the origin. Okay. Normally we label amplitude next. I don't have an amplitude to label. We're not going to label anything with our vertical stretch. Vertical stretch is just visibly seen by how you draw your graph. So we'll talk about that when I actually draw the graph. Okay? I mean, it's, when I talk vertical stretch, it's, am I going to draw a graph that's more straight up, or is it going to take its time going up? Like, those are the differences we're looking at. Okay? So this is more of a stretch. It goes straight up. This is more of a flatten. It runs closer along the x-axis. Okay? So that's more of how you draw the graph. That will come in at the end. Okay. We have a period of pi over 6, yes? So that means what I'm going to do is I'm going to label pi over 6. I'm going to require you to draw at least 2 cycles of your tangent graph and cotangent graphs. Okay? Now,
3 asymptotes.
it depends, possibly. So I'm going to label, and I have room to use here, so I'm going to label this as pi over 6. Now, if I say I want at least 2 cycles, then what else should I do? I should probably do 2 pi over 6. What is 2 pi over 6?
3.
Pi over 3. I'm going to put 2 pi over 6 down here just as a reminder, like I did 1 pi over 6, 2 pi over 6. Technically, that's 2 cycles, yes? That's 2 cycles worth. Now, keep in mind, what do we also have to do, though? We also are supposed to shift pi over 6 left. So what should I probably do on the left? We should go an equal distance of negative pi over 6 left. Okay? Try and keep them equal distance. Okay. We've essentially got 3 periods worth there, is what we've essentially got. With sine and cosine, we always took 1 period and broke it into 4 pieces. I don't need 4 pieces here. We're just going to do our halfway points. Okay, so all I really need here are my halfway points, which means, can you just put a tick mark in the halfway points? You can. What would a halfway point be? What's the middle of 0 and pi over 6? A half of a sixth, right? 2 times 6 is 12. So for the record, that would be pi over 12. I'm not going to say you have to label all your pi over 12s. Okay? I'm just trying to get some good fraction practice in here too, I guess. Okay. Now, I don't do a let's graph the original curve on this and then let's shift it. It gets too messy. We go straight to the final answer. Okay? Now, we are graphing tangent. Tangent starts with what? A point or an asymptote at the origin?
Point.
Tangent starts with a point, right? So, now, officially, there would be a point there. I'm getting ready to erase that, though, because that's where my point should begin. But we have a phase shift. So where am I going to shift my starting point?
Negative pi over 6.
So I'm going to shift to that starting point, pi over 6 left, which means it's going to shift to negative pi over 6. That is going to be one of my crossing points, one of my zeros. Now, what I ask you to do, once every period, go put the points. So a period is pi over 6. So once every pi over 6, I need another point. So where's my next point going to go? At 0? Where's my next point go?
Pi over 6.
Pi over 6. If you even wanted to keep going, where would your next point go? 2 pi over 6, which is pi over 3. Now, I just drew 4 points. Technically, I can draw 4 curves and have 4 cycles just like that. So it's so easy to draw extras here. Sine, cosine, it wasn't that easy. It's so easy to just have extras, and that's fun. Now, you have your points placed. In between points, at the halfway points, are going to be what then? The asymptotes. Okay, so now I'm going to go in and put the asymptotes. So in between negative pi over 6 and negative 1, there's going to be a asymptote. So that's negative pi over 12. There's an asymptote. In between 0 and pi over 6 are my points. So there's going to be an asymptote at pi over 12. Officially, in between pi over 6 and 2 pi over 6 if you want, there's going to be an asymptote. And you can keep going. Okay, you can put the end asymptotes in, but you don't have to. Okay. Now, you're pretty much ready to draw this. I guess the one thing I will say, what I look for is there's usually one cycle that I require to be there, if that makes sense. And that would be the initial cycle, which would be this one right here, yes? So with that in mind, that graph definitely needs to be there because that's the one that represents my phase shift to the left. If you want, could you put an appropriate asymptote on the left? You can. I know we didn't really mark that, but you can put an appropriate equal asymptote, right? Okay. Tangent is an increasing curve. This graph is more stretched than flattened. So I'm going to draw a graph that looks like such. In between my asymptotes, crossing at negative pi over 6. Then I'm going to repeat the process. In between my next 2 asymptotes, I'm going to put an equivalent curve, crossing, this time it's at the origin, staying in between my asymptotes. Officially, since this first cycle was my main cycle, you can be done right there. We don't even need this extra information. But it's real easy to draw a third here because we already have it set up. So you can draw another increasing stretched tangent curve. Okay, guys, questions I should answer. There's similarities, right? But man, there's a lot of differences. Okay. Shall we go try a cotangent curve? I think we got time to get it in. Let's move with it. See if we can get this in. Okay, on the back side, guys. Cotangent curve. We'll talk about that. Okay. Yes and no. Center line is what? 3. Am I going to vertically stretch or flatten this? Because my A value is less than 1. My A value is 1/2. And again, I just want to ignore the negative, right? We're going to vertically flatten, officially by a factor of 1/2. But I don't really pay attention to the factors. Gosh. Now, what did you guys catch at that point? There's a negative, and a negative means it's going to reflect. And of course, we are reflecting across the x-axis. Okay. What about the period? Pi divided by b. When that says x over 2, realize the coefficient of x is 1/2. So pi divided by 1/2, which is pi times 2 over 1, which is indeed 2 pi. And a phase shift.
Pi over 2, pi over 4, 1 over 2.
Okay. C over B. Opposite the signs, this is going to be positive. Pi over 4 divided by 1/2, which is pi over 4 times 2 over 1, which is 2 pi over 4, which is pi over 2. And that is going to go to the right, pi over 2. Okay. Before we go too far, cotangent curve. A couple of things. What does a cotangent curve look like? Officially, it is a decreasing curve, yes? So that's what a normal cotangent curve should be. But what's the catch? We're reflecting. So instead of doing that, it's going to look like a tangent curve. Okay, here's the deal. It's going to look like a tangent curve, but what are we still officially graphing? Cotangent. So when we come to what do we start with? Do we start with a point or an asymptote? The cotangent rule says we'll start with an asymptote. Does that make sense? Okay, so it's still a cotangent graph. It's just going to physically look like tangent. Okay, let's get some labeling in. Center line is 3. I'm going to give you guys a heads up right now. It is so easy to forget that center line on these because you don't have to count up and down. And man, so easy to forget the center line. Okay, we got center line. I don't have any other y values. Period of 2 pi. Which means, okay, I'm going to go out here and I'm going to label 2 pi. Keep in mind, I only used half the graph because 2 pi is 1 cycle. How far do I want us to go? 2 cycles, so I'm also going to go ahead and label 4 pi. Now, if they're not equal enough for you, adjust. I feel like mine are a little wonky, but nah, we're going to go with it. They're not too bad. I see a lot worse when grading your guys' sometimes, so. Okay, so that right there represents 2 periods of cotangent, yes? There's a but here. There's a phase shift. What's that phase shift?
Pi over 2.
Pi over 2. So I have to represent pi over 2's on here as well. Now, hold on, let me back up a moment. 2 pi is 1 cycle, yes? I said you had to mark the halfway points of the cycle. So what are the halfway points? Pi and 3 pi? Okay, that would be what you'd need for the regular cycles. However, we're also going to need to throw in pi over 2's because that's my phase shift. Where's pi over 2's going to go? In between all of them. And we're going to the right, so we need 1 past 4 pi. So this would be pi over 2. Pi is 2 pi over 2. So this is 3 pi over 2. 2 pi is 4 pi over 2. So there's 5 pi over 2. 3 pi is 6 pi over 2. So here is 7 pi over 2. 4 pi is 8 pi over 2. So here is 9 pi over 2. Again, I'm not going to say you have to label your halves. Okay. We're graphing a cotangent curve. Cotangent starts with an asymptote. Cotangent starts with an asymptote. It starts with an asymptote at the y-axis. But, what's the but? We're going to phase shift that asymptote where? Pi over 2. So now, My asymptote that should be at the y-axis is at pi over 2. How often am I going to put another asymptote? Once every cycle. So once every period, we need another asymptote. My period is 2 pi, yes? From pi over 2, where is 2 pi? And it would be 5 pi over 2. Now, if you're saying, whoa, 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 I don't like that, here's the deal. We were 1 tick mark past 0. Now we are 1 tick mark past 2 pi. Where's my next asymptote going to be?
9 pi over 2.
1 tick mark past 4 pi, right? Because my asymptote should have been at 0, 2 pi, and 4 pi. They each got shifted 1 right. Asymptotes are happening once every period. Where do my dots go? In the middle. So my dots end up at 3 pi over 2 and 7 pi over 2. This is a reflected cotangent curve. Cotangent, I'm getting ready to erase this, would do like that, right? But we're not doing that. It's reflected cotangent, so it's going to be increasing and it's vertically flattened. So you'll notice as I approach the x-axis, my graph kind of flattens before it goes back up. That's how you're going to show a flattening. As I approach the x-axis, it kind of flattens out and then starts increasing back up. Okay? There's a cotangent example. Tomorrow we'll practice another tangent and cotangent, and then you should hopefully have some work time.